This is our hotspot lab. What we're investigating here is the movement of both Pacific and North American plate over a hotspot. A hotspot is a location in the Earth's crust that is underlain by an unusually hot magma plume. What happens is that magma plume will burn through the crust, create a volcano, either a volcanic island or a volcano on a continent, and then as the plate slides over the hotspot, it creates a series of volcanoes, the oldest volcanoes being the ones that are further from the hotspot. Now, usually volcanic activity is associated with either divergent or convergent plate boundaries. Hotspots are a little bit different. Depending upon the hotspots, as they're found on page 5 of your Earth Science reference table, represented by this little explosion-like mark, hotspots can be found pretty much anywhere. Some hotspots, specifically the Hawaii hotspot and the Yellowstone hotspot and the Canary Island hotspots, are right in the center of tectonic plates. These are not locations generally associated with volcanic activity. Ones I've seen questions on are the Tasmanian hotspot, Galapagos Island hotspot, all popular hotspots to have Regents questions on. So, the one that we're going to concentrate on for this lab is going to be the Hawaiian hotspot and the Yellowstone hotspot. For the Hawaiian hotspot, we have this map on the front. You'll notice that there are a series of islands in the Hawaiian Islands, the oldest islands being the furthest away from the currently active volcanoes here on the main island of Hawaii. You'll also notice that the older you get, the further you are away. So that means that at some point, these islands, such as Midway Islands, were right here over the hotspot, and that as the plate has slid, the older islands get further away. Now, you'll also notice that each of these volcanoes has a little white dot in it. Whenever we make our measurements, we need to use those white dots. It's kind of like a standard for where we're going to be taking our measurements from. To do this assignment, you're going to need a calculator, and you're also going to need an index card. So, the data table here is on the second page for the Hawaiian hotspot. We need to find the distance between these two volcanoes in kilometers. We then need to calculate it to centimeters, and then find the differences in age. The first set we're going to look at is the Hawaii and the Maui-Naui complex. Hawaii is right here. Right here. The Maui-Naui complex is here. And you'll notice that there's two little white dots there. So I'm going to take my index card. I'm going to align it along so I can still see the white dots. And I'm going to put a mark on my index card right next to the dots. I can then slide over to my scale. And I see that they are 200 kilometers apart. So I'm going to take that 200. And I'm going to put it on my distance in kilometers. Now we need to convert to centimeters. There just so happens to be 100,000 centimeters in each kilometer. There's two ways you can do this. You can either plug into your calculator the 200 and the 100,000, or you can put your 200 down, and because there's 5 zeros and 100,000, we simply can add those 5 zeros to our number, and you'll come out with the exact same thing, 20 million, that you would have if you plugged it into the calculator. The next thing we need to do is we need to look at the difference in age between these two islands. The Maui-Naui complex formed 1.2 MA, or millions of years ago. If you remember back to when I talked about geologic time, I said there'd be a bunch of different ways you'd see millions of years ago. Usually we use MYA, but for this particular assignment it says MA. Hawaii is still erupting today, so that's 0 MA, or 0 million years ago. The difference between the two, 1.2 and 0, is going to be 1.2. However, because we're in millions of years, we need to convert that into normal notation. So 1.2 million years is going to be our difference in age. So 1,200,000 years. We next want to calculate our rate for these times. So we'll bring that information down to our second data table here. We're going to put our distance between the two islands in centimeters, so our 20 million on top. 20 million. And then our difference in age. This just so happens to be 1,200,000. That's centimeters. 1,200,000 years. When we multiply that out, divide that out, you're going to get about 16.6 repeating. But since it asks us to round to the nearest tenth, we're going to put 16.7, and our units is centimeters per year. That's pretty much the same procedure for all of these. You just got to find the distance in kilometers, convert it to centimeters, find the difference in age, and you're all set. Get all the numbers plugged in. Repeat the procedure for the Yellowstone caldera, and then use your information to answer the critical thinking questions for each individual part. If you have any questions, you can email me.